Okay, today we are going to talk about scientific notation. Okay, scientific notation, what is it? It's like an abbreviation. It's a way to write numbers that are really big and really small and to make them easier to understand and operate with them, or to calculate with them. Here are some examples. So this number, it's not 3, it's 5. And it will be in miles. So this number shows us the number of miles that is from Earth to the closest star outside of our solar system. And you agree with me, it's a really big number. So in a science we can we not can we just use a lot of very small numbers like this. So this time, because it's in second, this tiny number shows us the amount of time that it takes for light to go from one side of an average-sized bedroom to the other side. That's about 30 feet. So can you see? This is tiniest number. So, and for example, this one. It's 0, it's going to be 0. And I need to count my zeros. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oh, I need additional zeros. How can I do this? Okay, I can do this. Yeah. 6 goes here, zeros go here. Yeah. Now this is correct. So and this will be units, atoms. So this is the number of atoms in an average sized glass of water. And you can see it's like almost impossible to operate these numbers. This is a very, very, very tough idea to operate them. So, and I'm just going to repeat that scientific notation help to operate with very big and very small number and makes them more understandable. And I'm taking another color. I am going to write in green. So scientific notation use base, something base, multiply by 10 in the power. The power can be positive or negative. So this is the way mm, to show these numbers. So let's do some examples. So we have this first huge number of miles, and together we are going to write it in a scientific notation. So the first of all, we need to understand where is our decimal point is. The decimal point is not shown here, but it have to be here, and it is here. If it's not shown, so it is at the end. So our decimal point is here. And what I'm going to do, I'm going to move this decimal point to the left. So I will be moving it here to the left, and I need to stop my decimal point um, having my base having just one digit at the left of my decimal point. So, and I'm counting spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And here will be my new decimal point. Should I write all these zeros? No. No, I do not. I get rid of all these zeros. And remember, we moved our decimal point on a 13 spots to the left. So that means that I need to use 10 in the power 13. So this exponent shows us the number of spots we moved our decimal point. So let's recalculate, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, I'm correct. So when I moved decimal point to the left, I made this number smaller. But using 10 in the power of 13, I am making this number the same like previous. So this is the way to write amount of miles from the Earth to the nearest sun, to the nearest star outside of our solar system in scientific notation. So it will be 2.53 in a 10 multiplied by 10 in the power of 13. Okay. So by the way, how many significant figures are there? And you know, non-zeros are significant. So 1, 2, 3. 3 significant figures. Okay, the next one. For the next one, I will be using purple. Okay, so here is decimal point already. It's given, yeah, it is shown. And I need to move it to the right. Why? Because the rule is saying that this base actually need to be less or equal to 10 and more or equal to 1. So if I move my decimal point here, 1, 2, 3, 4, 5, 6, 7. Can I put it here? If I put it here, I will have my base here 0.2. It's less than 1, so no, I cannot stop here. The next spot. So here will be the new place. So 2.03. And let's recalculate on how many spots I moved my decimal point. 1, 2, 3, 4, 5, 6, 7, 8. 8. So, okay, 8 spots. So when I moved my decimal point to the right, I made this number bigger. And now I have to make it smaller to get the equal number. So multiply by 10. And I will use, when I go to the right, I will use negative exponent. So it will be 2.03 multiplied by 10 in the power 8 negative. Okay? So the next one, let's do it, let's say rows. Okay? So, decimal point is not shown here, so we know it is at the end. So, and we are moving it to the left. And you know, when you move to the left, you will need 10 in the power something positive here, right? So let's calculate spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, then 15, then plus 3, 18, then plus 3, 21, then plus 3, 24. Can I stop here? What do you think? No, I cannot, because this number can be between 1 and 10. So I need to move it here. So 3.06. And I'm getting rid of all zeros. So I do not need zeros after non-zero digit. Okay? But this zero, which is between 3 and 6, I need to keep it, okay? So 3.06. And remember that we moved decimal point on 25, I believe. Let's recalculate. 1, 2, 3, 4, 5, 6, 7, 8, 24. Yeah, 25. So, and in scientific notation, this number will be 3.06 multiplied by 10 in the power 25. Okay, atoms. So you go left to the left, positive exponent. Go to the right, negative exponent. Okay? Okay, let's do opposite examples. We have numbers in scientific notation, and after we need to get regular number. Okay, so let's do this. For example, we have let's say 1.52 multiply by 10 in the power 5. What it will be, let's say liters. Abbreviation for liters is L, right? So this is the same as you write down all these numbers which are given as a base. So 1, 5, 2, and you don't need decimal point here. And after you pay attention to this exponent. So it's 5 here. That means that let's do this first. So first of all, you write down this number like this, 1.52, and instead of 10 in the power of 5, you will write it like this, multiply by 10, 1, 2, 3, 4, 5, right? Okay, and let's say I need to move my decimal point 5 zeros here means that I need to move my decimal point on a 5 spots, on the 5 positions to the right here. So 1, 2, I'm not calculating this, 3, 4, 5. So my new number will be 152 and 3 zeros. 3 zeros. You can check yourself and rewrite this number just to make sure that you did right, you did correctly. Rewrite this number in a scientific notation, right? So you need to move decimal point from this position to the left 1, 2, 3, 4, 5 to the 5 slots, right? And you will get 152 multiplied by 10 in the power of 5 liters. Yes, you did correct. So let's do the next example. Let's say 6.67 multiplied by 10 in the power 3 negative, right? What it will be, let it be grams, okay? So grams, 10 to the power 3 negative means that I need to move my decimal point to the left on the 3 position. So this is my decimal point here, and I will be moving it. So 1, 2, 3, right? And this will be the new place for my decimal point. So, and here I will write it like this, decimal point, and instead of these empty spaces, I will put zeros, 1, 2, and then 6. No decimal point here because it's already moved to the left, so 67. And no 10 in the power of 3 negative, just grams. And of course, you can use 0 here, so it will be like this. Okay? So you can do examples, next examples with me. And I suggest you pause video, do it by yourself, and then check it with me, okay? So let's do 2, maybe 3 more examples. Okay, so let me give you examples. So convert from regular to scientific notation and from scientific notation to regular numbers. So from regular to scientific notation. I like this. For, let's say, 0, 0, 0, 0, 0, 0, and it will be meters, okay? So, scientific notation requires us to have as a base a number which is in between 1 and 10. So I need to move decimal point here from this position to the left, and I'm counting spots 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be their new place for decimal point. So new way to write this number will be 1.234. I'm leaving non-zeros digits, right? And multiply by 10 in the power. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9 in a 10, multiply by 10 in the power 9, 9 positive, right? Because we moved decimal point to the left. The next one, 2 multiplied by 10 in the power negative 12, let's say. So, in the power negative 12. Nothing to the right of 2. That means that 2 will be at the end. 2, this is the first. And now I need 12 spots together before decimal point, right? So 1. And instead of spot, I will put zeros. 2, then 0, 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's recalculate. So with 2, it have to be 12 spots here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This will be decimal point, the new one here. Okay, you can check yourself again. So when you move decimal point to the right, it will get you 12 spots, right? And you will be getting the same number. So let's do another one, the last one. For example, it can be, let's say, 1 triple, another 3 zeros. So how many 3 zeros I have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and then I have 0, 0, 3, 6, 9 pounds. What is this number? This number is the weight in pounds of a proton, of a one proton. Weight in pounds of a one proton. Okay? So, and we need to write this number in a scientific notation way. Okay? So, we know that we need to move this decimal point to the right. So, and I believe that the new position for decimal point will be here because it will get us 3.69 as a base, right? So 3.69 here, multiplied by 10 in the power. Power will be negative because we are moving decimal point to the right. So we need to calculate spots. So I'm going to calculate it like this: 1, 2, 3, 4, 5, 6, 7, 8 gives us 24, 25, 6, and 7. 10 in the power 27 negative pounds. Okay, in next video we are going to discuss how to subtract and add numbers using scientific notation and how to multiply and divide. So for now, that's all.